sometimes when we're looking at bonds, we're not necessarily going to be thinking about the orbitals. There are other ways to model bonding. And one of those ways is through electron dot structures. Now, this requires a bit of knowledge about the periodic table. When we talk about bonding in the periodic table is laid out so that it highlights how many valence electrons an atom has. And so if you look at the far left side of the periodic table, it says row 1A. And the next one over says row 2A. That means that row 1A has 1 valence electron. Row 2A has 2 valence electrons. And if you go to carbon, carbon has 4A. It's in the row 4A, so it has 4 valence electrons. And so let's say we want to make methane. Well, in order to make methane, we need 4 hydrogens, and we need 1 carbon. So each of these 4 hydrogens is in row 1A, and so they each have 1 valence electron. And carbon is in row 4A, so carbon has 4 valence electrons. And so one way to draw these is to add these around carbon in some manner. So we'll put our carbon as our central atom. We'll put its 4 electrons around it. And then we'll come in and we will add our respective hydrogens with their bonds. Now, some people write it this way, which is perfectly fine, and in a minute I'm going to show you why that's perfectly fine. But other people will write it in this way. So we have got our hydrogens, and I'm going to use green in this case to show that it's a different version of the same thing. It tells the same story. These are called electron dot structures. And it's a very effective way to predict, to count, to know how many electrons are around atoms. Now, we can take this form and we can make one adjustment to it. So I'm going to redraw this one here. I'm just going to draw it down. I'm going to draw it a little smaller so I have more space. We've got our 4 hydrogens. We've got our carbon with our 4 valence electrons. And in this case, we can convert this into something called a line bond structure. Oops, LIND. And what we're going to do is we're just going to connect these dots and make lines. So I'll draw it again. And now we connect the lines. And so we have carbon bonded to 4 hydrogens. So that's another way of drawing the same thing. Both of these forms are effective. Both of these forms tell you the same thing. Anytime you see a line between 2 atoms, there are 2 electrons bonded between those 2 atoms. And so in this case, we have a carbon that has 8 total electrons around it, right? It satisfies this idea of the octet rule, where we have an electron configuration for that carbon of 8. Hydrogen, in this case, only needs 2 electrons around it to satisfy its Nobel needs and desires. And so hydrogen here has an electron similar to that, or electronic behavior similar to that of helium as it's bonded to carbon in this case.